Greetings students, welcome to another video from iCampSA. Today we're going to be doing a past paper question from 2024, and this is mathematics. The area of focus is functions. We'll be doing this is a November paper. So let's get into it. So for question we have question 4 for starters. Okay, we are given that f of x is equal to -2 over x. We are seeing that x in the denominator, which tells us we are dealing with what? With a hyperbola. Plus 4. That 4 is our vertical shift and the horizontal asymptote. Okay, so let's go ahead and quickly answer this question. So for 4.1.1, we are asked to determine the equation of the horizontal asymptotes of f. The equation of the horizontal asymptotes of f, we've already identified it. It's gonna be y is equal to 4. And then next we are asked to determine the coordinates of x-intercepts of f. X-intercept of f is 4.1.2. So for x-intercepts, what do? We let y equal to 0. We equate y to 0. Therefore, we're going to have f of x is equal to -2 over x plus 4. F of x is our y, so it's going to be 0 is equal to -2 over x plus 4. Let's solve for x. We put the 4 on the other side. 4 is equal to -4 is equal to -2 over x. Okay, the negative and negative will cancel. Therefore, we'll be left with x is equal to 2 over 4, of which is equal to 1 over 2. Therefore, that's the x-intercept, which is x is equal to 1 over 2. That is our x-intercept. Okay, and then next, for 4.1.3, we're asked to sketch the graph of f, clearly showing the x-intercept with the x's and the asymptotes. Okay, this is 4.1.3. I think we can try to fit this function here. 4.1.3. This is our x's. Okay, and then we have let me do it like this. Yeah, just to provide a little bit of space. Yes. Yeah, okay. This is our y-axis. X-axis, let's calibrate. Is 1 2 3 4. 1 2 3 4. Let's see what was there. Okay, the asymptote is y is equal to -4. Sorry, y is equal to 4, +4. Okay, 2 4 6 8. 2 4 6 8. Gonna use the intervals of 2 on the y-axis. 2 4 6 8. 1 2 3 4. Okay, -1, -2, -3, -4. 2 4 6 8. Let's start by drawing our asymptotes. Is at +4. This is where our asymptote lies. Okay, and we can see that the function is negative, so it means it has been reflected about the y-axis. Okay, so when the function is positive, it has the branches on the first and the third quadrants, or if it's negative, it has the branches on the second and the fourth quadrant. Okay, so what else? the intercept the intercept that we calculated, x-intercept, is at what? Is at x is equal to half here. That is where our graph will intercept the x-axis. Okay, so we don't have the y-intercept because our graph doesn't actually cut the y-intercepts. Then once we have that, we can essentially sketch our function. It's gonna be of this nature. That's the function we're gonna have, and then the other branch will be here on this side. We said we have to clearly show the intercept to the axis and the asymptote. The asymptote, we said it's y is equal to 4, and then the intercept is 1/2 and 0, and that is your function. Okay, and then for 4.1.4, we are asked to determine the equation of g if g is formed by shifting the graph of f 7 units downward. So the graph of g is formed by shifting the graph of f 7 units downward. So for 4.1.4, let's start by writing the graph of f is equal to, what is it, negative, is it 2 over x, negative 2 over x plus 4, and then the graph of g is formed by shifting the graph of f 7 units downwards. Therefore, in other words, we are being told that the graph of g at x is equal to f at x minus 7 units. So g at x is equal to negative 2 over x plus 4 minus 7. So therefore g at x is equal to negative 2x plus 4 minus 7. It's gonna be negative 3. That's the equation of the graph of g, which is essentially the graph of f shifted 7 units downwards. Okay, and then let's go to 4.2. So for 4.2, we are asked to determine the coordinates of the graph of h at x is equal to 2 to the power of x. X is an exponent, therefore we are dealing with the exponential equation. We are asked to determine the coordinates of a. A is what? Is the y-intercept of the graph, and then we also have b, which is the x-intercept of this exponential equation. So a is the y-intercept. We are asked to determine the coordinates of a. So for y-intercept, we let x equal to 0. So we have what there? We have h at x is equal to 2 to the power of x minus 2, and then we let x equal to 0. So h at 0 is equal to 2 to the power of 0 minus 2. Therefore y, which is h at x, or h at 0 in this case, 2 to the power of 0 is going to be 1 minus 2, of which would be negative 1. Negative 1. What were we looking for? Coordinates of a. So we have to represent it in the coordinates formats. We're going to have 0 and negative 1. 0 and negative 1. And then next, we're asked to write the range of h. The range of h, in order to be able to write it, we need to realize that we have the asymptote there. The asymptote is represented by that constant, of which also represent the vertical shift. So the asymptote is y is equal to negative 2. So our graphs only exist above negative 2. So for 4.2.2, the range is y is greater than negative 2. That is our range, where y is greater than negative 2. That is where our graph exists. So for 4.2.3, we also determine the equation of j. If j is formed by reflecting the graph of h about the y-axis, about the y-axis, we are asked to determine the equation of J. Equation of J. Okay, so we have to reflect this graph now about the y-axis. About the y-axis. So in order to reflect the equation about the y-axis, the equation will now have it will be a decreasing function. That's first thing first. So it's gonna look like that. That's the equation of J. And then, so in order to reflect this function about the y-axis, we need to introduce a negative sign, but we're gonna introduce it where on the x-axis, sorry, on the x values, so for 4.2.3 J at x is gonna be, we're gonna have the same equation but with a negative sign. So we're gonna have 2 to the power of negative x minus 2. That is the new equation, and then let's write it in the formal way. Therefore, J at x would be, what is 2 to the power of negative x? It will essentially be 1 over 2 to the power of x. This will be 1 over 2 to the power of x to the power of x minus 2. Okay, yes, so that is that will be your answer for the reflected version of the graph of H. Okay, and then next we have question number 5. So it reads as follow: sketch below are the graphs of f at x is equal to ax squared plus q. We already know that we are dealing with a what? With a parabola. Okay, and the straight line G is parallel to the x-axis. It has no gradient. It's parallel to the x-axis. Coordinate S is what? Is 4 and 0. The x-intercept of f. The graph of f passes through point T. It passes point 2.3, P and R. So it passes, those are the points. So we know that the parabola has what you call this thing, it has what is it called, the axis of symmetry, about the y-axis. It has the axis of symmetry about the y-axis. So we know that those points are just reflected versions of the points that we have given. So instance for R is what is negative 2 and 3, and then P is what is negative 4 and 0. So those are the points. Oh, okay, would you look at that? We are just given the coordinates of, we are asked first thing first about the coordinates of P and R, which is what we've just written there. Coordinates of P are what? Minus 4 and 0. And then that is A. And then for P, the coordinates of R are what? Coordinates of R is minus 2 and 3. Okay. And then next, we are asked to write the equation of G. G is what? G is a straight line. It's just a straight line that cuts the y-axis at 3. So the equation of G is simply gonna be, doesn't have a gradient, so 5.1.2. G at x, that's right, it's in this form. G at x is equal to what is it? 3. Is equal to 3. Essentially, the proper way is just to write it as y is equal to 3. And then next we also determine the values of a and q. So I guess we'll have to do this using simultaneous equation, because we have two unknowns, but we also have points that lies on that function. So this is 5.1.3, 5.1.3. So for 5.1.3 we have f at x is equal to ax squared plus q. Yes, plus q. Okay, let's take one coordinate and substitute it in places of x and y. So let's start by s, 4 and 0. 4 and 0, so it's 0 is equal to a times 4 squared plus q. We'll call this equation, or let's actually make q the subject. We're gonna have q is equal to negative a. What is 4 squared? A multiplied by 16. That will be our equation 1. And then for equation 2, let's take the other point, which is t, 2 and 3. So 2 and 3, we're gonna have 3 is equal to a times 2 squared plus q. So we're gonna have, let's make q once again the subject. We're gonna have q is equal to 3 minus a times 4 for a, basically. That would be equation 2. So we have q as the subject in both of these equations, so we can simply equate the two equations. So we have negative a times 16 is equal to 3 minus 4a. 3 minus 4a, 16a. Let's solve for a. So I suppose everything, we have negative 16a plus 4a is equal to 3. Negative 16a plus 4a is negative 12. Therefore, we have 3 is equal to negative 12a. We divide by negative 12 on both sides. Therefore, a is equal to negative 1 over 4. That is a. And then for q, we can substitute it into the first equation there. Q is equal to negative 16a. Q is equal to negative 16a. Let's substitute our value of a to find q. Q is equal to negative 16 multiplied by negative 1 over 4. This will be 16 divided by 4 is 4. Q is equal to 4. Those are the values of a and q. What is q? Q is also our turning point. So here the value of q is what? The value of turning point is what did we find? That q is 4. So it's 0 and 4. Okay. If f at x okay is equal to k, determine the values of k is equal to k. Determine the values of k for which f has no x-intercepts. So in order for the graph of f to have no x-intercept, it has to be below that 0, so k has to be equal to, it has to be below 0. So we are asked to determine the values of k. K essentially has to be less than 0. So this is the values of k less than 0. That would be 5.1.4. 5.1.4. Okay, let me see. If f at x is equal to k, determine the values of k for which f has no x-intercept. Okay. Determine the values of k for which f, the function of f, has no x-intercept. The values of k if f has determine the values of k. So here I think we have two scenarios. If determine the values of k for which f at x has no intercepts. Values of k for which. Okay. The statement can be interpreted in different ways. This is 5.1.4. 5.1.4. So in order for the function of f to have no x-intercepts, the values of k let me see, if k to have 0 x-intercept. Okay, I'm trying to think of a scenario where we will have 0 x-intercepts. Let's quickly write this formula. We have f at x is equal to, what is that, -1 is equal to -1 over 4 to the x squared plus 4, if I'm not mistaken, plus 4. Yeah, so to have no x-intercepts, if f at x was 4, or maybe let's start with, if f at x is 0, is equal to -1 over 4 x squared plus 4, we put there. Okay, we will have no real roots. So if f at x, which is k, is less than 0, we will have no real roots. First thing first, that's what I see. Let's see. If f at x is k is 4, then we have 0 is equal to -1 over 4x squared. So a negative of 0, again we have no real intercepts. So basically we have these two conditions where k is less than 0. Yes, let me see. If it less than 0, let's say -1, -4, we're gonna have a irrational number. Basically it's a non-real number, and where k is greater than 4, I see if it makes sense. K is greater than 4. K was 5. We're gonna have 5 minus 4 is, where k is greater than 4. 5 minus 4 will be -1. Okay, we'll have no real root. So it's for those two conditions whereby the f at x will have no x-intercept, it will have no real root. Okay, so for 5.1.5, determine the coordinates of f if f is a reflection of t. about the x-axis, coordinates of f, reflection about the x-axis. So it's only reflected about the x-axis. This is 5.1.5, 5.1.5. We're looking for the coordinates of f. So if it's reflected about the x-axis, it means the x coordinates doesn't change, only the y coordinates changes, so we're gonna have 2 and -3. Okay, 2 and -3. And then 5.1.6 a, using the graphs, determine for which values of values of x, f at x minus g at x will be greater than 0. Values of x where f at x minus g at x will be greater than 0 will be a positive number. So we basically have to look for those values of x whereby the graph of f is above the graph of g. So I think from here to here, that is when the graph is above. So when we subtract the graph of g from the graph of x, we will have positive value. So it's from -2 to +2, basically, where x, it's where x is greater than -2 but x is less than 2. Let's write it in the formal way, proper way. So it's where x is greater than -2, x is greater than -2 but less than 2. Those are the areas. So those are the values of where x, and then for b, where f at x multiplied by g at x gives us a value of where f at x multiplied by g at x will be less or equal to 0. So we're looking for a negative or a 0 number. So we're looking for when they are opposite. So from here, from p to whatever, from p to x, both they are above the x-axis, so they are both positive, therefore they will give us a positive number. But from -infinity to -4 and from 4 to +infinity, when we multiply the two graphs, we will get a negative outcome. Let me see. At -4, actually, it would be 0, so -4 would be included. I just wanted to put that there. Okay, so this is where x is the element from, we said, from -infinity to -4. -4, it's included, or x is the element from +4 to +infinity. You could write it like that, or we can use that interval, we can use the interval notation, which is x, where x is less or equal to -4, or x is where x is greater or equal to 4. Yes, and there you have it, folks. That is how you'll go about answering that question. This one is from November, if I remember well. So we have 17 marks and let's see, and 12 marks. So that is about 17 plus 12 is gonna be what, 29 marks. 29 marks, and the November paper is out of 100 marks, so about 30% of the paper, So okay, So yeah, that is that. I hope you learned something from this video, and until we meet again, I wish you good luck and good study.